Okay, so here we are in 5.4b, and we already calculated the answer to 5.4, example 4b, using a calculator, and you might remember we got 1/4, or actually I think it was 1/2. But I would also like to show you how to figure this out without a calculator. So what we did yesterday was we just popped this into our graphing calculator. We did math 9 on it, and that was giving us the answer to this integral with an absolute value sign in it. Also I want to remind you that this function here that I've circled, that's the velocity function. So we're integrating the absolute value of the velocity function here, and of course that represents the total distance traveled. So what we need to do is we need to figure out when this velocity is positive and when it's negative. Because when it is positive, the absolute values will act on it differently than when it's negative. So we're going to go off to the side and solve that inequality. So we've got t cubed minus 3t squared plus 2t, and we need to figure out when this is positive. But the way you solve an inequality is you start out by setting it equal to 0. So I'm going to factor out the t. And then this will factor it into t minus 2, t minus 1. So the solutions are 0, 1, and 2. So when this velocity equals 0, that's where the velocity might change from positive to negative. So then we put those cutoff points on a number line. Now, since our integral is only from 0 to 2, in this particular problem, we don't care what's happening below 0, and we also don't care what's happening above 2. So we really need just to test these two intervals to see whether the velocity is positive between 0 and 1 and whether it's positive between 1 and 2. So we pick a representative point and plug that into the velocity. So for example, 1/2. So I think this is the easiest form of the velocity to use. So that would be 1/2 times negative 1/2, times negative 1.5 times negative 1/2. And I'm not exactly sure what that number is, but I'm sure that it's a positive number because I have a negative times a negative times a positive. So that tells me that in between 0 and 1, this inequality is going to be true. The velocity is going to be positive. On the other hand, pick a representative between 1 and 2. That would be 1.5. That would be 1.5 times negative 1/2 times positive 1/2. Which of course comes out to a negative number. So that means the velocity is negative between 1 and 2. Okay, so since the velocity is positive between 0 and 1, when we're doing our integral over here, we can split this up into two integrals. We can integrate from 0 to 1, and then later we can integrate from 1 to 2. Now this velocity inside the absolute value signs, is positive between 0 and 1, according to that work we just did. Absolute values don't do anything to a positive number. So since this mess is positive between 0 and 1, I can just get rid of the absolute value signs. So I was allowed to drop the absolute value signs because this is a positive number. An absolute value doesn't do anything to a positive number. On the other hand, between 1 and 2, what I've circled here, the velocity, is a negative number. So the absolute value is going to take that negative number and make it positive. Another way to take a negative number and make it positive is to multiply it by negative 1. So that's what I'm going to do here. I'm going to take this velocity, take that velocity function and multiply it by negative 1. That makes it positive, which is what the absolute value signs would have done anyway. So now I can do these two separate integrals to figure out the integral of the absolute value. To make things a bit easier, I'm going to carry this -1 in front of the integral. A constant can come in front of an integral, so that'll make this minus. So now I just need to take the antiderivative, plug in 1 and 0 and subtract. Then take another antiderivative, plug 2 and 1 and subtract. Okay, so the antiderivative is t to the 4th over 4 minus t cubed minus, plus t squared. And I'm going to do 0, 1 and subtract. And then I'm subtracting that other part, which has the same antiderivative, from 1 to 2. So I've got this mess minus that mess. So now I'm going to go ahead and plug in 1 and 0 and subtract. So this is that. Same thing here. I'm going to plug in 2 and 1 and subtract. There's what I've got. Okay, so those 1s will cancel, so this is just 1/4 minus, so that's the total of the first bracket. And then for the second set of brackets, I've got 16 divided by 4, so 4 minus 8 plus 4 minus 1/4 minus 1 plus 1. So that's 1/4. Let's see here, this all comes out to 0. So I've got 1/4 minus 0 minus 1/4. So that's 1/4 minus -1/4, which is 1/2. And that's what we got before. So now we know for sure that the total distance traveled on this particle is 1/2 of a meter.